Electromagnetic launcher, review of various structures. A theoretic review of electromagnetic coil-gun launcher and its types are illustrated in this paper. In recent years, conventional launchers like steam launchers, chemical launchers are replaced by electromagnetic launchers with auxiliary benefits. The electromagnetic launchers like railgun and coil-gun elevated with multipole field structure delivers great muzzle velocity and huge repulse force in limited time. Various types of coil-gun electromagnetic launchers are compared in this paper for its structures and characteristics. The paper focuses on the basic formulae for calculating the values of inductance and resistance of electromagnetic launchers. Keywords: electromagnetic coil-gun launcher, EML, inductance, coil-gun types, multipole field EML. Introduction. The first prototype of EML tested as aircraft in 1946, termed as Electropole, electromagnetic launcher, replaced all traditional launcher with acquirement of more benefits, viz. eco-friendly, eliminates complex mechanism, reduce volume and weight, launch high-weight objects, can be renewable, less maintenance, less risk, less manpower. 1. Since then, electromagnetic launch, EML, is attracting researchers for development of launching technology. EML system uses concept of linear electric motor to accelerate a projectile. This is used in wide-range military application, aircraft launching, anti-terrorism weaponry, electromagnetic mortars, missile launcher to launch toxic waste into space, acceleration of objects with extremely high speed. There is a need to convert electric energy into kinetic energy. In this process, huge amount of energy loss takes place in conversion process 2. Electromagnetic have two basic categories, i.e. railgun launcher and coil-gun launcher. 3. Coil-gun launcher is differentiated by its design structure and properties in 5 categories: induction coil-gun, reconnection coil-gun, reluctance coil-gun, helical coil-gun, Thompson's ring. EML consists of excitation and acceleration coils, projectile or object, capacitor charging circuit, capacitor bank, triggering switch. This paper is mainly focusing the basic principle of electromagnetic coil-gun launcher, inductance and resistance calculations, construction and modeling concept of different coil-gun launcher. 2. Working principle. Railgun has 2 parallel rails from which object is launched. When current passes through the rails to the object, it produces arc. Because of high current pulse, it has more contact friction losses. 4. Compared to the railgun launcher, coil-gun launchers have no contact friction losses as there is no electrical contact between coils and object. The electromagnetic coil-gun launcher consists of capacitor bank, solenoid coils and projecting objects. 3. The coil-gun launchers have series of solenoid coils which accelerate the projecting object placed inside the coils. These coils use electromagnet in the configuration of linear motor to accelerate a projecting object. The object and coils are arranged on common axis. Capacitor bank delivers large electric current to produce strong magnetic field essential for acceleration of projecting object. 3.5,6. The capacitor bank delivers high current pulse given to the excitation coil. The electric current energizes electromagnetic solenoid coils, electromagnetic force generated by Fleming's right-hand rule. Magnitude of electromagnetic force experienced by object is represented by the Lorentz Z-force given by. The magnitude of EMF induced in circuit is proportional to the rate of change of flux. The electromagnetic force of coils attracts and launches projectile the direction of induced current in magnetic field. The object is propelled by force generated in the direction of common axis through the accelerating coils around the object. As there is no mechanical friction, the velocity of projecting object is becoming very high. To achieve maximum projectile velocity, multiple coil design is suggested. 5. In multistage coil gun, the force creating process is repeated in every stage. 3. Inductance and resistance measurement. For computation of mutual inductance of coils, traditional Fawzes/Borkas, Williamson/Leenards, and Grover's numerical methods are used. To avoid singular cases in integration by using L'Hopital's Rule 9, new combined analytical and numerical method used for calculation of magnetic energy. 7. This method includes skin effect, so the current distribution is non-uniform in conductors. It divides cross-section of conductors in mesh. 9. The final answer of this method gives closed-loop function in terms of Jacobian elliptical first and second order function and Humann's lambda function. This method is applicable to thin-wall solenoids, disc coils, 2 coaxial circular coils. 7 to 9. Inductance of non-coaxial coil is calculated by using Bessel function as it gives inductance as one-dimensional integral of closed-loop function. 10. There is only difference between coaxial and non-coaxial coil is a last term of Bessel function in non-coaxial coils. This method is applicable for cylindrical coil, thin solenoid coil, pancake coil, circular coil. In multipole field electromagnetic launcher, inductance is calculated on the basis of position of projectile. Inductance of coil is calculated when a. Projectile is completely inside the coil and b. Projectile is completely outside the coil. Let is a position of projectile 11 to 12. When projectile is completely inside the coils, then maximum and minimum value of inductance is achieved. Reluctance of magnetic circuit is equivalent to the resistance of an electric circuit. As there is magnetic field produced by coils, so reluctance of coils required to calculate 11. The basic formula for reluctance is: force generated on projectile is calculated from electromechanical energy conversion principle, which use magnetic field as coupling medium between electrical and mechanical system. That shows electric energy produced by capacitor bank transfer into catapult coil, which energies acceleration coils to create magnetic field. The projectile inside the acceleration coil experiences mechanical force given by 14. Force generated on projectile is: force depends on mutual inductance and magnetic diffusion process in coil. Categories of coil gun launcher. Coil launcher can be categorized into 5 types: I. Induction coil gun launcher, 2. Helical coil gun launcher, 3. Reconnection coil gun launcher, 4. Reluctance coil gun launcher, and v. Thompson's ring. I. Induction coil gun launcher. Induction coil gun launchers have high conversion efficiency. When coils were fired, eddy current induced in projectile, which produces repulsive accelerating force. To produce a greater force at beginning, at the bottom of coil pancake coil added 4. It accelerates heavy projectile to much higher velocity. 2. Helical coil gun launcher, 3. Reconnection coil gun launcher, 4. Reluctance coil gun launcher, v. Thompson's ring. It is a higher voltage model of induction coil gun. Initially spiral coil charged through capacitors, then Thompson's ring creates its own magnetic field, which is adversely to magnetic field of coil. The repulsion between the magnetic field accelerates ring upward. Induction coil gun launchers are basically differentiated as 15. A. Asynchronous. The driving coils may be connected in series or in parallel and energized with a certain time sequence. The relative movement between the projectile and the traveling wave induces current in the projectile. B. Synchronous. The driving coils are stacked end to end and energized sequentially to provide an impulse force to accelerate the projectile. The velocity of the projectile is exactly equal to that of the electromagnetic traveling wave. 16. This involves separate drive coil and launch coil. It launches both hollow and solid projectiles. It operates at lower current and higher efficiency compared to induction coil gun launcher. The driving coil is fixed on shield material like air shield, conductive shield, and ferrite shield. 17. This coil gun type had a shape like disc. Acceleration coil is made of 2 coaxial copper coils and projectile is plate shape locate in gap between 2 accelerating coils. External coil produces time-varying magnetic field which induces current in a conducting plate. A current is pulsed through the coil and produces eddy current which propel the projectile. It works on principle of reluctance motor. 18. Uses attractive ferromagnetic properties to accelerate the projectile. Coil is magnetized by carefully timing the coil current, and the attractive forces of coils pull the projectile upwards sequentially. 5. Its energy conversion efficiency is higher than the inductance coil gun because electrical energy conversion only takes place at excitation coil, so there is negligible eddy current in the projectile. 19. Timing the current pulse is crucial parameter of this launcher, otherwise it can experience suckback effect. 5. Multiple field electromagnetic launcher. To propel object or projectile in space with extremely high speed and in limited time, it requires huge repulse force and long durative time simultaneously. To achieve this, multipole field electromagnetic launchers are used. 4. Multipole field electromagnetic launcher have big caliber and multistage structure in which multipole acceleration coils in one stage charged simultaneously by capacitor bank. 20. The acceleration coil with pulse current inducts the projectile to generate eddy current. Authors. 21. Proposed multistage twisty multipole electromagnetic launcher structure in which the second stage of coil is twisted by some angle to first stage for better performance. It results as accelerated speed and magnetic torque of rotational motion is larger and transverse displacement of projectile is less. If the system is excited by sinusoidal current flowing in saddle coil moving in axial directions. Each driving coil produces magnetic field which direction along radius of cylinder. Thus, radial magnetic flux density with loop eddy current produces large axial thrust force, and then radial compressive force decreases. Radial magnetic field can be generated by increase in no of poles, but complexity also increases. The connection pattern of driving coil should be like it can generate magnetic field in both inward and outward directions simultaneously to get magnetic lines reconnection. Author. 24, proposes toroidal field electromagnetic launcher with new accelerator mode to avoid catapult coil. It utilizes toroidal magnetic field interacting with radial current to generate axial accelerating force which avoids catapult coil for initial launch speed. Toroidal magnetic field interact with radial eddy current by axial acceleration force. Without catapult coil launcher has great axial acceleration force. Double armature multipole field EML having the armature are placed inside as well as outside of driving coil 25 to improve efficiency but muzzle velocity is similar to single armature launch.